Hello everyone. So today I'm going to work on this. When I can normally run like this, and when I press shift, character will be able to run like Naruto, like this. And if I jump here and press shift again, we can run on the walls like this too. So this is the part I am going to cover today. We can run on vertical surfaces. We usually can't do that with the normal character we have in Unreal. We can use the same thing to implement a game like Spiderman 2, because in Spiderman also we can run on buildings like this. Alright, I think this is enough of the demonstration. So let's see how to implement this system. This episode is sponsored by this generous patron, Mental Treason. So this is what I want to achieve at the end of the day. So this running on walls. Exactly this effect. As you can see, the character can run on the walls like this. So this is what I want to implement in Unreal Engine. Alright, so first part is I have this character with the standard idle and a running animation, and when I press shift I want this character to sprint with that Naruto anime style running animation. For that I have already imported this Naruto run animation. I think this should be faster. Maybe like this. Okay, so this is what I want to do. So in my character, this is the third person character, and here let's open the third person animation blueprint, which is like this. And here in the animation graph, we for this idle run we are using this blend space, this one. So here it's 375. Let's set the maximum axis value to 600. And divisions, let's say 6. Okay, what's the character speed? Alright, 600. Okay, right. Well, actually I'm not sure if this animation speed matches with the current running speed. So to find out, let's do this. When we calculate the speed, let's print it. and then here let's see, yeah, this is 600. Okay, so if we slow down time, we can see if the character speed matches with the actual ground movement represented by the animation. So to see that, let's use this key, this slash key. If I press it, let's do a flop here. If I press it once, I'll set global time dilation to 0.2. If I press it again, let's set it to 1, which is the normal value. If I do that, and after pressing this key, I can see. So as you can see here, there is a little sliding happening on the ground. So that means animation speed, we have to speed up the animation a little bit. So actually this should be here. Let's try 1.1. Oh wait, right, 1.2 seems to work better. Here is the demonstration. See, no more sliding on the ground. Okay, now I want to implement sprinting. So I'll increase this to 8 and set the speed value, increase it to 800. Now I'll put this back to 600 and put Naruto run here at the 600, at the 800, like this. Okay, now let's go to inputs. And action mappings, we don't need this VR thing. Sprint. Let's use left shift for that, and then let's implement action event sprint. When I get that, I'll set max walk speed to, let me promote this, sprint speed, it should be 800, and I'll have another variable let's change this, speed run, speed sprint. Speed run should be 600. Right, when I release it, I should set max walk speed to the running speed. Oh. Alright. Alright, now let's see what happens. Now this is normal running. If I press shift, you can see character is running like this. This is normal run. Press shift, character is running like this. Okay, let's see if the animation match the actual speed. It doesn't. We can see some sliding. Actually, if I fix it here, that would be better. No, still there is a little sliding. Yeah, I guess that's okay. No, that's alright. Yeah, what if I set the sprint speed to 700 and set this back to 1.3. and put it in the 700. I think this is better because that animation was too fast when I want to do with 800. Still sliding, but we don't see it when we go in the actual speed. Alright, now we have implemented this. When I press shift, we can go to this anime running. Right, so now I want to start implementing jump into a wall and run on that wall. So let's add a cube here. Let's make it big. Maybe too much. Okay, so when I go there, if I jump and press shift, I should start running along this wall. Right, I changed the wall material like this. Okay, now I'll close other tabs except the third person character. I don't need the settings. Okay, now how to actually run on walls. So this is for sprinting, right? Okay, we already have the jump, and if I press sprint while I'm on the jump, that means here let's have a branch. He's falling. Here I'll press show can wall run. So what I'm trying to do is, if I press shift while I'm on air, the character can do a wall running. I need to implement other stuff first, later, but first let's print this and see if, yeah, we get that return input there in the top left. Okay, now if I can do a wall running, what I would the next thing is I need to find if there is a available wall that I can run on. So to detect the wall, I'll do a sphere trace by channel. A starting point is get at the location, and the end is get control rotation, and from the control rotation get forward vector. And so what I'm trying to do is I'm gonna scan the forward area, the area that I'm looking at, to see if there is a wall. So let's multiply this by 500 units, and add to the current location, and that's the end. Trace channel visibility. All right, okay, let's see. Okay, we got a hit there, and I think 500 is not enough. Let's try 2000. Oh, maybe that's too much. Okay, like that. Right, now we can detect the wall, so then we should actually start on the running on wall. Okay, now if I detect a wall, let's break the hit result, get the impact location, And first let's set our set movement mode to fly. And then move component to the impact location and keep the rotation without change. Alright, now we need to limit this movement and also need to rotate the character to the wall. Okay, right, so how to rotate the character? We can get the normal, get rotate, rotation from X vector, and so let's try this. I'm not sure what would happen, but let's try this anyway. Set rotation. Okay, I'm sorry, let's use a line trace. That would be simpler. So like this, but actually the problem is this normal gives us the new up vector of the character, so that means this. So see, now it's correct, but the only problem is now we need a way to find the forward of the character. So even if I jump to the wall like this, the character rotates the back to this way because it doesn't know where the forward is. So to find a new forward, let's do let's collapse this. Let's call it move to wall. We have to do another line trace. If this one is successful, line trace by channel. Here also the starting point is the same, character location. No, let's try something else. We can get control rotation, get up vector, multiply this by 50. So this is to get a point higher above the controller, the camera, and that should be the starting point, and the ending point is add this value. Let's see if we get 2 ray castings. I think I didn't see that properly. Let's break this for now. Sorry. We need to, for the start location, this is the ending location. That's correct. No, that's not correct. We should add this to get the start location. Right, this should be the start. So we should have 2 ray casts, line traces. Like that. Oh wait, I should add here. Okay. But I see only one ray. Where's the other one? Alright, let's skip this branch for now, and let's make the debug type persistent for both, so that we can keep the lines. Right, there are 2 lines. Okay. Alright, so that means, right, now I get the lines as I want. So what I'm trying to do now is this. Here, let me take a screenshot. Now I'm going to use okay, let me explain. Here, now I can get the normal of this point, so it would be something like, oh, what happened here? Let me take a screenshot again. So in this case, if it is in a so I can get the how reduce the width of this normal of this point like this. So this is going to be the z vector, and this direction from this point to this point is going to be the x. So right now let's do this. If there is a hit, we can do the next one, and also here also there should be a hit if both conditions are correct. These are okay. Break this, break the second hit result, and here I can get the location. Then I can do no, I can get this location and subtract this one and get normalize this. So we can get a direction vector from here to here. Then we can, I hope I'm doing this okay, make rotation from zx. So z is this one, x is this one. Let's see what happens now. Right, it worked. Okay, now we get the rotation correctly. So let's add another variable on wall, and here let's set on wall to true. Right, now let's go to the moment inputs. So here I'll collapse this part because this part will get bigger. We should add input like this only if we are in walk-in mode. That means if on wall is false. Let's do the same. Also here I need to set disable all the movements. otherwise it would be a problem. What happened? Okay, it's correct. Oh, let's do this. Instead of doing it like that, let's move component to. Let's do this. Maybe let's set a sequence here. Better, yeah. So while we go to that location, we can rotate the mesh. So relative location should be, let's see, I'm gonna keep the visibility of the capsule in the game so that I can clearly see what's happening. So how to rotate this character? Okay, like that. What if we attach the camera boom to the mesh itself? Oh, wait. Rotation needs to be changed like this, and location should kept same. Should be kept same. So minus 97. Wait, that's wrong. This is relative. Okay. So to get the relative rotation, split both and get word rotation of the capsule component. Split this one too. Now we need to subtract the world rotation of the mesh component and this one. We need to subtract the world location of the capsule component from the world rotation of the mesh component to get the relative rotation of the mesh component. Hope that is clear. This is how we do it. Right. Okay, now we are on the wall and we can't move. We will work on that in a moment, but it is working. Let's try again. Right, working. So what if the wall has an angle like this? I think it should still work. Yeah, it does. Okay, so one more thing. So in order to properly work, the character should move here. So we need to modify this part a little bit. To this, add the half height of the capsule. And then move to that location. Right, now it is working properly as I intended. Oh yeah, okay. Now how to restore movement? Right, to restore movement, we need to check if we can actually move. So in here, let's first work on the move forward. Let me add a reroute node here and collapse. Move forward wall. Right, now here we need to do a check, a line trace, another line trace, to see if we can move forward. So get control rotation, get forward vector. Oh, we need the axis value also here. Get the forward vector and to align trace by channel. Start point would be the location and end point would be this, plus multiply this by some value so we can get the forward vector with some length, let's say 200. For duration, but I want to see what happens. Right, okay, the check really happens. But yeah, maybe instead of using the character location, let's use a bone, maybe knee location. Now let's add the socket. Let's name it, okay, root socket is good, and let's move it. It should face forward. Okay, and now instead of this, so let's use that location. Get socket location. Okay, I think that's better. For another 800. Okay, if there is a hit, let's add a movement input to the character. One more thing, can we add another pin here? No. Alright, so then we need to multiply this by okay, so first we need to make sure that this one is not equal to 0. If it is 0, no point doing this traces and everything. Select this based on the value here. If this one is larger than 0, well, actually we should not be able to run backward in the wall because that doesn't make sense. Well, that doesn't make sense to begin with, but also yeah, I don't think we can. Okay, so this should be 800. And if this is true, let's add movement input in the direction of how to get the direction. We know the location of this one. Let's subtract this value from the starting point and normalize. Okay, now we can work on the wall, but we need to work on the rotation of the character too. To match with the new direction. Well, I think we can do this. We can get the normal make rotation from Z, sorry, from ZX. This is the Z, and how to get the X? Well, this would be a little, it would be wrong, but let's use it anyway. Get set world rotation. Get world rotation, and then lap to this with 0.1. Let's see. Okay, it worked. Right, that's a good starting point. Let's make it completely vertical for testing. Well, let's try this one because that one kind of feels not smooth. Get 12 seconds. Yeah, that's the problem I have. See, it's not correct. Let's see. Alright, maybe if I enable this. Okay, so I think we should control the moment when flying. I'll set this to 1. What's the general value for this? Break in the acceleration when walking, 248. Is that value enough? Let's see. Yeah, let's use the same value for wall running as well, because we need to control the moment. also we need to correct the foot location as well. Right, we should be able to fix it here. When we do the move to wall, relative location, if I read it like this, oh wait, we can't fix it here, but we can fix it here. Yeah, let's forget about this part. Let's keep this only for the moment. And in the tick, do we have the tick here? No. Let's have a branch. If we are on wall, let's see the root. Right, here, get the mesh, get socket, transform in the world space, root. What I'm trying to do is do a line trace and adjust the character rotation and the location to match with the surface. So split line trace by channel. Start is this and end is get up vector, because this is the up vector. Do we have a down vector? No. Alright, not a problem. Multiply this by minus 80 and add to a branch. If there is a hit, break this. Now this is a world location. We need to move our character mesh to that location, but in the local space. Well, I can't do the calculation, so let's add a scene component. Root as a child of the capsule, and then I'll get the root, set world location of that like this. Oh wait, we can do the same for the mesh too. Yeah, set location, world location and rotation. like this. Get word transform of the mesh. Let's split this, and we can do a lerp, so we can have a smooth transition from here to there. And so for the rotation, get the normal, make rotation from ZX, and this we can have from get velocity. The X we need to calculate from the velocity. There will be a problem here, but let's see. Where's the line trace? Oh. This should be multiplied by minus. Okay, something is wrong. We need to lerp this one too. That's the problem. Why does it keep going like that? Shall we use the root socket instead of the root? Well, let's try something else. Do you remember this root component I added here? Yes, let's move it down like this. and then let's use that as the starting position. Get world location. Right, now we are not moving anywhere. And we rotate back because if there is no movement, right, that's because of this. If there are no movement, the character rotates. Let me see. If there is no velocity, this x becomes 0, 0, 0. So to prevent that, let's get vector length vector length. If this one is larger than 0, we can select this vector like this. If the speed is larger than 0, then we should use this. Otherwise we should, oh no, we can simplify this like this. Select plot, like this. If there is no speed, then we will not keep rotating to 0. Right, see, if I stop, it just stops in the current location. So if I look at this way, I can't move because my line trace does not work, as you can see there. So to fix that, what we can do, one more thing. Here in the movement input, for the direction calculation, I was using this one, subtract this one. Instead of, let's do it like this. Instead of root socket, let's get the actual root. That would give us better results. So in this case, I can't move because of the line trace doesn't hit. So to prevent that, maybe instead of doing the check like this, let's see, we can do something like this. Let's make it like this and use this point as the starting point, and for the end point let's see, root socket up is like this, so down. Okay, get socket rotation, root socket, get up vector, multiply it by minus 200 and add to this. That's the end location. So we should be able to always move like this. Oh, we need a way to detect edges. Let's see what happens when we try to work on a space with an angle. Oh, it works basically anywhere. Okay, here we should use max fly speed as 800. Then we will have that Naruto movement. See? Okay, now we need a way to jump off from the wall. So maybe to do that in here, if we don't have a hit, we can set on wall to false and set movement mode back to falling. Okay, now if we do that, we need a way to restore character rotation. So we can get the mesh, move component to relative location is minus 97, relative rotation is 0. Well, let's cut this part. Now let's collapse this to a macro. Stop wall movement. What happened here? Okay. Right, but why am I still doing this trace if I'm not on wall? Right, maybe I should set this to false, not true. All right, let's see now. Okay, why can't I get on that? All right. All right, so let's finish this part. Here we have some issues if I enable on wall right here, so I will not enable it here. I will enable it only after finishing this part. Set on wall, because sometimes I can't get on this wall. Right, now it is okay. Alright, so I'll stop this episode at this point. I think I have one more problem. Here I think we should use an upper bone instead of root socket, because sometimes I don't get a hit with this 200 with this 50. So yeah, so therefore instead of this I'll just use get actor location. Sometimes I have trouble getting a hit if I use the root socket location. And there is a shaking effect. Well, the system is still not perfect. We have some glitches, but this is a good starting point. Okay, and one more thing. While I'm here, if this is less than, if this is false, then I should call stop on wall, because if there is no movement I should not be able to stay idle on the wall. And also if I jump while on the wall, let's jump. Let's collapse this. If I jump while on the wall, I should stop moving on wall. If on wall, if it is false, just jump. If it is true, stop on wall and then jump. Right. Okay, now I can get off from the wall. Also, what if I hit the floor? If I run like this and if I hit the floor, wait, I can't use the actor location here because if I use, so actor location is on the well, I'm not sure how it behaves, so I can't turn while on the wall if I use it. So I can't turn properly, so therefore let's use maybe not root socket, let's try pelvis. Right, now it works properly. And the other thing I need to fix is, what if I hit wall floor? See, this is what happens. I need to fix that. So to do that, we can get this normal and break. If the Z component is 1, that means we are on a vertical, we are on a horizontal flow. So equal, let's use nearly equal. Point 1. Branch. Then also we should stop on wall. See, it stopped. Okay. Oh wait, this should be equal to 1, not 0. Let's try again. Seems like there's a problem in here. Sorry. This is okay. These should be interchanged. Because if the Z component is closer to 1, that means a horizontal surface. Right, now it works. Okay, so that's our final demonstration, and I'll stop this episode at this point. So I'm going to stop this episode at this point, and the project file will be available through the Patreon page. Link could be in the description below, and thanks for watching. So if you like to support my work, you can get the membership of the Patreon club. See you in the next episode. Goodbye.